Hi everyone, Molly here from LearnPedia. Today we have Nafis with us, another one of our trainees who's shown great performance in our residential design traineeship program. We are going to have a quick chat so you can get to know about his technical skills, his upskilling journey in the Australian residential design and construction field, and how he's been applying what he's learned to the real life projects he's been working on. So whether you're an employer looking for someone who's ready to hit the ground running or just curious about what our training programs look like in action, this video is definitely for you. Nafis, it's really good to have you here today. So let's start with a foundational question. Nafis, can you tell us a little bit about yourself?
Yeah, I'm Nafis. I'm a final year civil engineering student at Monash University. I've completed my residential design and construction traineeship, and that's really informed me about how I go about designing and constructing residential dwellings from start to finish. And right now I'm just looking to secure a job in the civil engineering field, ideally in the residential space, but I'm also open to working on a variety of major and minor infrastructure projects as well.
Perfect.
Yeah.
Great. Thanks for sharing that with us, Nafis. Now, let's
Yeah.
just switch to some technical questions. The first question, Nafis, is that when designing a subfloor system on a standard site, so no flooding or special conditions, what design checks do you carry out for the footings supporting the barriers?
So in this case, when designing a subfloor system consisting of bearers supporting floor joists, the bearers are supported by concrete stumps and pad footings. So the first consideration is the soil bearing capacity. So the soil bearing capacity, you'll find that information in the geotechnical report. And the geotechnical report will provide information such as site classification, footing founding depth, and in certain cases, advice on designing for tree effects. But I mean, given that there's no special conditions, tree effect isn't necessarily important in this case. So the second consideration for designing the pad footings is the lateral stability component. So lateral stability generally refers to wind loading, but can also refer to seismic loading as well. So the reason that this needs to be considered is when wind acts on the footing, it can cause an overturning moment. And as such, you have to design the footing such that the resisting moment is greater than the overturning moment. And design the footing using software packages such as Structural Toolkit, and you'd input design parameters such as footing geometry, soil properties, and various other factors as well. And the final consideration is the uplift force. So you need to ensure that the wind load that is pulling the footing up will not exceed the combined dead load of the structure and the side friction forces of the soil acting against the footing. So yeah, again, you'd use Structural Toolkit to also design this this pad footing, and between these three considerations and the three pad footings you've designed, you choose the most conservative pad footing for this subfloor system.
Perfect. Such a thorough answer, Nafis. And just opening up a bracket here, it doesn't have to be a pad footing necessarily, as in the outcome may be a deep footing system, right? Rather
Yes,
than just a pad footing.
yeah, sometimes board piers can also be used. Yeah.
Perfect. All right. On to the second question. What factors do you consider when specifying lintel sizes in a single timber stud wall?
So in a single timber stud wall, one design check that needs to be carried out for lintels is that the depth of the lintel section must be below the maximum available wall height above the openings. And another design check is for the lintel thickness. It can't be above 90 mils, which is the stud depth of itself, like in a standard timber frame. So in this case, the chosen lintel size must not stick out of the wall, for instance.
Yep.
So beyond this, something that needs to be considered when calculating the design action acting on the lintel is the self-weight, the roof pitch, the tributary area, and any associated point loads and UDLs acting on the lintel. And these loads will form the basis for determining if a section is adequate in terms of ULS and SLS design. So just to apply this a bit more, I'll just provide a brief example. So for a 90 by 45 MGP10 timber stud wall frame, let's say we have a maximum 220 mils of spacing between the opening and the top plate, so the max wall height above opening. So we'd start with, for example, a 90 by 45 MGP10, and then we'd increase the section size until 190 by 45. So that's again a standard section size. So we can't exceed that. We can't go past 220 mils. So we can't use a 240 by 45 section size since this is above the maximum spacing requirement.
Yep.
So again, if none of these sections work, you can also increase the timber grade. So you can choose grades such as MGP12, F17, KDHW, high span, or Smart LVL15, and then you'd design it such that it would meet the ULS and SLS design checks. And information about how you actually go about manually designing these elements can be found in AS 1720.1, and deflection limits can also be identified in AS 1170.0 and 1170.1.
Yep.
And so in the event that like a single non-laminated section doesn't work, you could also use laminated timber beams. So again, you repeat the process using a laminated 90 by 45 MGP10, and then increase the section size and grade where necessary. But again, here in this particular case, you have to keep in mind that the total lintel thickness does not exceed the 90 mils. So for example, let's say we have a laminated 130 by 63 mils high span. You can't exactly use that since 2 times 63 equals 126. That's about 90 mil thickness. So yeah, for that reason, you can't use that. Some of the factors that you can also consider is like builder preference when determining timber grade and section sizes for the design. So you can just send an RFI like by email to ask for their preferred sections and timber grades. But you can also do research yourself and look into commercial and market availability for timber sections when designing. So if you have that knowledge, you can also just make sure that all your design sections are readily available for purchase by builders.
Perfect. So you're considering also the shortage of a specific timber grade at the time in the market in your design. Perfect.
Yeah.
Thank you so much, Nafis. It was really detailed and thorough. So let's move on to the third question. Can you walk me through the bracing design process for a residential dwelling, let's say a single-story dwelling?
Okay, so first step will be to determine the wind catchment areas. So you go to the architectural drawings first and check the elevation views of the architectural drawings. So north, south, east, west, your cardinal directions. So you'd start by measuring the difference between the finished floor level and finished ceiling level. You'd find the midpoint of that distance, and then from that midline, you measure the area from that midline to the most extreme edges of the roof. So not just the ceiling, but the roof itself. And details about the actual process are explained in more detail in AS 1170.2 as well. So you'd repeat this for all cardinal directions of like each of the elevations, and then you'd also account for any projected areas, and you'd calculate those parts separately. So next would be to calculate the design wind pressure. Typically, this will be a value in KPA. Yeah, you can use AS 1170.2 to calculate the wind pressure in terms of ULS, in terms of the ULS and SLS design wind pressure, but generally software such as Structural Toolkit is used.
Okay, so you calculate the wind load in each direction, and then you check the design for that direction. Is that what
Yes.
Yeah. Okay.
Yeah.
Perfect.
Yeah. Then the third step would be to just to determine a preliminary bracing layout system. So some general rules of thumb when you're designing a bracing layout, you need to be able to brace the external corners. So that just ensures strength and stiffness of your bracing layout, since if you brace the external corners, you're preventing any torsional forces. You also need to brace the internal walls and distribute the wind load a lot more evenly with internal wall bracing units. Some example bracing units are plywood bracing type H method A and B, metal strap bracing, portal frames, and commercial bracing systems such as power truss braces and narrow wall bracing units. So details for this can be found in AS 1684.2 and AS 1684.3, as well as the relevant span tables for the commercial bracing units. And so bracing units are generally chosen depending on available wall width and the minimum wall width needed for a bracing unit. So for example, with the metal strap bracing, generally for those walls, you need 1.8 meters to 2.7 meters of wall width to actually install a metal strap. So next, you'll need to design for serviceability. So first thing you'd have to do is do a wind classification based on wind region and site conditions. So you do that based on AS 4055. Generally, higher speed wind classifications reduce the max spacing between adjacent parallel bracing units. So what that means is that the SLS requirements are a bit more stringent in that regard. So if you have like a N3 or N4 wind classification, your spacing requirements might not be as lenient as an N1 or N2. So for N1 and N2 wind classes, the spacing between parallel bracing units is must be below 9 meters, but for N3 and N4, you might start getting values such as 7 to 6 meters, for instance.
Yep.
So that's for the SLS checks. Now, for the ULS checks, this is the final step. All bracing elements in the longitudinal and transverse direction are calculated separately. So you need to calculate the capacity by multiplying the force over unit length of the bracing system by the width of the actual bracing unit itself. So then you just have to add all the bracing capacities of all the units in the north-south direction, and then you compare it with the ULS and SLS checks, ULS and SLS design loads in said direction, and then you'd also do the same for the east-west. Now, something to note as well, for wall heights that are above 2.7 meters, so max wall heights that are above 2.7 meters, you have to multiply by a capacity reduction factor. So, for example, for the max wall height of 3 meters, you'd have to multiply design capacities by 0.9, and for a max wall height of 3.3 meters, you'd multiply it by 0.8. If for whatever reason the ULS or SLS check fails, then you'd repeat steps 3 to 5 and iterate until successful.
Okay, perfect. Now, on to the last technical question. Nafis, if a stakeholder calls you, let's say a builder or an architect, and requests a change to the design, do you act on the change requested based on the verbal instructions, or do you follow another process? How do you tackle a case as such?
So if I was to receive a request for changes made by a builder or architect by verbal instruction, well, ideally, they would provide any requests and changes by email, but let's say that they called. If they did call, then I'd send an email back referencing that call and then explaining what I understood from their call. Because when you go off verbal information, things can get lost in memory and in translation. So I'd make sure that the changes that I want to make are also the changes that they requested of me. So it also helps inform like my engineering team about any changes that have been made, since there's like an actual paper trail of what's happening.
Yeah, perfect. So you do seek for a written confirmation or description, so you have a clear scope for the change requested. You also have a written trail that you can refer to if and when it's needed. All right, perfect. Thanks, Nafis. Now, the last question is about your career goals. When we started the conversation, you touched based on that, but this is a specific question about the career goals. So what sort of challenges or opportunities, Nafis, are you currently looking for in the field? And how do you see yourself contributing to the team you're joining?
In terms of current challenges I'm seeing, at least in the field, I recognize that there's a challenge in the residential field in the form of housing shortage. So I believe Engineers Australia did release like a 2023 report on the matter, or several years ago on the matter, and that generally impacts like all sorts of people, like homeowners, landlords, tenants. And so given that I've completed a traineeship in residential design and construction, I think this makes this challenge somewhat of an opportunity for me to actually successfully design and construct residential projects. In terms of how I would actually behave and act in an engineering team, I think that first and foremost, I would demonstrate integrity and accountability in my designs. So what this means for me basically is that I understand that my designs and any structure I design will have a tangible impact on the communities that I build for. And as such, I need to design to the best of my ability, since if I don't, then injury, loss of life, and legal action against the company I work for may occur. And then, following on from this point, I will also do my absolute best to remain competent as an engineer. And as such, I will ensure that I'm continuously learning, whether that's learning about new construction techniques or new software packages such as like Revit or Civil 3D, for instance.
Perfect. Thank you so much, Nafis, for sharing your experience, your knowledge, your journey with us. It's always rewarding to see trainees who not only absorb the knowledge, but also apply them confidently in the real life projects assigned to them throughout the traineeship program. And you've shown fantastic performance in the traineeship. Well done, Nafis. Now, if you're a hiring manager or industry professional watching this video and want to connect with a job-ready professional like Nafis, feel free to reach out to him.
Thank you, Molly. Thanks,
Nafis.